So before we design any component, there are some pre-design considerations that we have to look into. So the first one, as you might have guessed till now, this is the soil conditions, because we are talking more of infiltration and groundwater table and things like that. So it's really important to understand, like, let's say I'm going to put a SuDS component at a certain area. So I should be aware that what kind of soil is there. So we know that if the soil type is clay, the infiltration is very less. So, we cannot do anything about it. We cannot infiltrate any water. So we have to think of a certain different component of SuDS, which does not concentrate more on infiltration, but on some other technique. So for soil conditions, we'll see the type, the permeability rate, and the bearing capacity, of course, because we'll put some structure or so we should be knowing how much load the soil can take. Then what is the site type? That is it a greenfield or it is a brownfield? So in greenfield, you have to match the greenfield runoff rates. For a brownfield, if there is already a development and then you plan on taking off that development and building your own house, then you have to match whatever rate is currently being discharged from that site. Then the groundwater table, it has a major significance as discussed in the infiltration, and also if the groundwater table is very high, we cannot provide SuDS there because it can rise up and create some disturbances to our calculation and the design. Then the general site topography. So as we have seen in the principle of surface water management train, so first prevention, then site control, then source control, then site control, and then regional control. So all these are hierarchy, and also it starts from a upstream to a downstream. So upstream areas are usually high on elevation, and the downstream are usually low in elevation. So we have to see the general topography. So accordingly, we can plan these SuDS components. Then we also have to see the flooding in the area. So we have to go and read the flood maps or do some interviews around the areas, like how is the flooding pattern? Is it every year or once in 5 years or something like that? Then the discharge conditions, as in the second concept. So where are we discharging? Are we discharging it to the river, streams, or to some existing drainage systems or infiltrating? So all this information has to be collected before even thinking of the component. And the last is the operation and maintenance evaluation. So it's really important in SuDS that we have to decide on who is going to operate and what will be the maintenance frequency of these elements or the components. And the last but not the least, health and safety risk assessment. So for example, one of the SuDS component is an open pond or a detention basin. So just imagine if we create a pond in a residential area and we do not think anything about the health and safety risk, there might be some very big accident. So that is very important. And it is not just important with SuDS, it's also important to do this health and safety risk assessment for all the projects. Okay, so now let's see some of the techniques which are there, or the components of SuDS. So starting with rainwater harvesting systems. So these systems are not new, and most of us might have seen it in some of the other form. So these are basically underground or overhead tanks which collect the rainwater which is falling from a roof or surrounding areas, and we collect it and then use it for multiple uses like cleaning, washing, flushing. And based on our usage, these water can be treated. Let's say some people don't want to directly use this rainwater for cleaning their clothes, so they can provide appropriate treatment technique. And this tank is basically designed as per our usage. So let's say in one day I require 100 liters of water. So based on that, the sizing of this tank is done. However, the rain can be less or more. So for less, we have alternate sources that is coming from our water supply network. For excess, there are certain other arrangements given, like an overflow arrangement, so that extra water can go out and maybe infiltrate or maybe join some public sewer, or that depends on site to site, and that is done project specific. And as all of you might know that this rainwater harvesting is not a very new concept, and it has been practiced from the very ancient times and cultures. So this below picture is such an structure which is called in Bauli. And in Delhi, in and around Delhi, you see a lot of structures like this. Moving on to the next component, these are the green roofs. So yeah, it's actually a roof. So it's a planted soil layer which is constructed on the top of the roof. So this is the roof deck, this orange one, and there are certain other layers. So this is a protection board, then a waterproof membrane so that water should not seep in, then an insulation layer, and then these drainage storage. These are plastic boxes in very simple language. Then a filter fiber, and then a growing medium, and on a growing medium like soil and all, and then the plants. So on the top of your roof, this planted soil layer is constructed. So when the rain falls on this, it is absorbed by this soil to up to its field capacity, and after that, the extra rain comes to these plastic storage boxes. And once the rain stops, later in the days, this water is again used by the plants. So essentially, if you plan a green roof, whatever water is falling on your roof is not coming down and contributing to the public sewers or other pipes or other municipality infrastructure. In addition to these green roofs, there is also a blue roof. So the only difference in that blue roof is these plants are not provided, and in place of these growing mediums, there are gravels that are provided. So they provide a void space and water stands there. So basically, it is more of a storage structure than to evaporate or evapotranspiration. So moving on to the next one, these are the swales. These you might have seen in India, but they're not designed specifically. So along the road, you have seen these vegetated channels. These are used to convey water from one end to other. So sometimes they're used for conveying water. Sometimes the water just stands here and infiltrates below the ground. So these channels can be wet or dry based on the requirement and the infiltration rates. So in wet swales, water remains permanently at the base of the swale somewhere here. And in case of dry swales, the water just fills during the storm events and then just infiltrates. Also, these channels can be, like this. So this one is a vegetated channel. We can also have a lined channel. So in lined channel, it just resembles to the conventional drainage system channels, where we just use those channels to collect the water from the road and just let it go to downstream. Then the bioretention systems. These are nothing but shallow landscape depressions, which allow the surface flow to temporarily pond in these depressions, and then either filtering down through this vegetation into the underlying layers of soil and then eventually to groundwater table. Or it can also, like one more benefit is reduces the pollution of that water and ensures that the groundwater quality is not hampered. In a simple term, some of us might have heard of it as rain gardens, which is not so much used in India, but like in the European countries, this rain garden concept is used a lot. And sometimes, as you see that there are small gravels also. So sometimes we also put some engineered soil, that is gravel or a sand layer, to increase the efficiency and the pollution reduction capacity. Next is the filter drain. So this is nothing but a trench which is just constructed on the side of the road. So whatever water falls on the road, it due to the cross fall of the road, it goes into these ditches. So these are gravel layers basically, and then it goes there and it gets stored. So either it is conveyed downstream by these pipes, or it all infiltrates. So in areas where the infiltration rate is not that good, so there we provide this pipe which has holes, it has perforations. So once the water comes in through this layer, rises up, and then goes through the perforations into this pipe and then conveyed downstream to some other public sewer or that. So in this picture, it's a bit clear. So these are two filter drains. One is this, the other one is this. So the top layer is the sand layer to provide some treatment, and then this is a gravel layer, and then this pipe is there. Next one is the pervious pavement. So as we have seen that here, the road is not pervious. So whatever water is falling, most of it goes into this trench. However, there is, in this SuDS, we have moved one step higher. We also say now, let's make this also pervious. So we provide certain solid blocks or porous paving or porous concrete or grass pavers through which the water can infiltrate. And if you see in this figure, so there is this again a sand layer, then the gravels, and then the under drain pipes. And in this image, this is a layer of pervious concrete. So you see that water is falling and it is percolating through this concrete. Moving on to the next technique is the attenuation tank. So I think you remember when we were discussing about those graphs. So I used the word of attenuation. So it's basically reducing the peak flow. So to reduce it, we need some storage tanks or some kind of storage. So water comes into these tanks and stays here and then discharged in a controlled manner. So so we build these underground tanks and we fill it by gravel, or sometimes we also use this plastic boxes that you can see in these images. So the water comes here, it stands. Sometimes we also, if the infiltration rate of the ground is very good, we try to use that. So if we are considering infiltration, that the size of the tank gets reduced. So basically there we have just one inlet and two outlets. One is going to the public sewers and one is going to the infiltration. So the size is greatly reduced. The next one is the ponds and wetlands. So this is basically a permanent pool of water that can provide both attenuation. So water can be stored here for a long time, and also the treatment of water, because the underlying soil layers, when it infiltrates, it gets treated. And the outlet from these ponds are also controlled. And these are big in size. So even if we have a higher rainfall event, these have capacity and to trap that water also. Okay. However, these ponds and wetlands are usually not advised to be created or constructed very near to the urban areas, as we discussed that it poses a health and safety risk, and also creates, when we create these, there will be biodiversity in the area. So there can be insect nuisance, bird nuisance, and things like that. So these were the 7-8 techniques or the components of SuDS, which I have discussed on a very high level. And each of the component requires a great amount of knowledge to design them, which I think it's due to the limited time of this webinar, we could not do it. However, you have a brief idea of what are the techniques and what are the basic philosophy behind these. Moving on to just quickly highlight on the softwares and the tools that are currently in the market to design these elements. So this is a comparative study that was done for 10 different modeling softwares all around the world. And in this web, this inner circle represents a value of 1, then this 2, then 3, and 4, and 5. So basically on a scale of 0 to 5, these softwares were rated for 3 different things. One is for water quantity, other one is water quality, and third one is spatial planning. So if you see here, this mouse software, this is an earlier version of MyCurban. Some of you might know MyCurban. So you see that all the 3, it has capability to design these sorts of component for water quantity, quality, and overall spatial planning. And the second one is SWMM. So these 2 softwares are considered to be the best among, at least among these 10. However, if you ask me, so when I am designing these components and I don't have to look that much into the water quality, I usually prefer Excel sheets to design these. And if there is a requirement to do the quality modeling also, I really prefer mouse or MyCurban because it has very advanced water quality algorithms, and it also has the capability of hydrological simulations in terms of rainfall generation, runoff routing, and simulating the drainage network hydraulics. In addition to these 10 softwares, there's another one which is specifically used in Britain, United Kingdom, and Ireland. That is called Micro Drainage Windows from Innovise. So that is again a very good software. It also does the hydrological routing and simulations, in addition to the design of these sorts of components. So moving on to the most interesting and the important section, the application of these components which we have talked about. So before I start, I just want to say that all this information about the case study that is presented here is kindly provided by Cambridgeshire County Council and Royal Haskoning. So this Cambridgeshire County Council worked in partnership with the Housing Society to create a showcase development that includes SuDS and flood resilience measures. So this project was located around 8 miles from Cambridge City in the UK, and it is called Lamb Drove. It was a medium density housing development, so approximately 35 houses per hectare. I can understand that it's a medium density when we see UK, but in India, the definitions are a bit different. So here, what we had to do is we had to provide a retrofit SuD solution because the layout of the houses, the roads, and the area was already agreed and fixed. So this was more complicated as everything was fixed, and then on that we have to provide some retrofit solutions. And the objective of this was to attenuate the entire rainwater for a 1 in 100 year return period rainfall event, and taking a 20% of climate change in that. So this image shows the area. So these gray ones are different blocks, like different houses. and then these roads and some green areas or some play areas were also planned and all were already constructed. And then these blue things you see here, these are the pipes. The pipes and these blue circles are the manholes. So the conventional drainage system was already planned, but then there was discussion like, let's not do the conventional drainage, let's plan some SuDS into it. So if you remember the management train, it says that first we have to prevent uh, the rainfall or the surface flow. So for the prevention, we provided certain water butts. These are nothing but big barrels. I don't know if you have seen those big beer barrels where in which they store beer. So something like that. So these were kept outside every house, and from the roof, a pipe was connected to these, and these were filled and then emptied into green areas or some grasslands or things like that. Then, because the area is so big, so just the prevention would have not worked. So then we went into the source control. So the first element which we thought of was providing green roofs. So we, on top of every roof, we provided green roof, which can provide a certain attenuation and reduce the runoff or the surface flow. Then we also proposed the permeable surfaces that we discussed, like the permeable pavings. So block pavers were provided along the roads. Then the other ones were the swales. So swales were like these vegetated channels that were provided. So in some cases, they were connected to other swales, and in some, they were just placed there independently because the infiltration rates were so good. So we can, so we were able to manage just these undrained swales, so that the entire water that is coming to it gets infiltrated. After that, again, some of the surface flow was remaining. So for that, we proposed site control measures that providing some detention basins. So some of the play areas, we converted it to these small basins where we can store excess water. So like when rainfall is very heavy, so some water can go in these basins. Apart from that, like from these rainfall events, these basins were mostly dry. Then the very last was the regional control. So a very big retention pond at the very outlet of this township. So as we discussed that these big ponds should be away from the urban area. So, meeting that criteria, we proposed this retention pond here. So any excess water from the site can come here and be stored. And sometimes, as we said, that the climate is changing and more rainfall is coming. So even sometimes the rainfall that came here and the flow it accumulated was overspilled. So in that case, we connected this pond to a water course, which was initially connected when we had those pipes and manhole system. So this was the complete project description where we applied this SuDS. And currently, since its construction, the performance of these SuDS element is being monitored, and the site is delivering promising performance as it was desired at the very start. So we have talked a lot about good things about SuDS techniques and how it can help us in various ways and providing multiple benefits. However, there are still some challenges into it. So the very first challenge is the adoption and the ownership. What it means is, like, let's say I have a house and I decided to go for a rainwater harvesting system. However, my neighbor, he does not want to, invest into some harvesting structure or something. So that ownership is missing. So I will harvest the rainwater that is falling on my roof, but my neighbor will not do it. So the water falling on his roof will eventually go to the public sewers and will create those problems again. So that kind of ownership should be there. And even if we don't do it on a house level, even if we decided to do it on a township level, so it's not very clearly defined like who will take the ownership of that. And like adoption is a word that is used in the UK. So let's say they build some system. So at after some time, the municipality or the government takes it over. So that process is called adoption. Then the second challenge would be linkage with the spatial planning. So sometimes, as I gave the example of the builders, two different builders with different brochures. So our builder one was very smart, and he gave very a great amount of green areas and also a pond within his society. But the other one thought that, oh, I don't want to waste my space into these things. Rather, I'll provide one more block of building, a tower. So that kind of linkage. So some people have different thoughts. So currently, we are facing this challenge that this development of an urban area or a society or a township should be integrated with SuDS and stormwater management. Then delivering of the multiple benefits. Sometimes, we have discussed 4 benefits to be precise, like quality control, quantity control, amenity, and biodiversity. So sometimes it's not possible to deliver all the benefits. So, but however, if we are able to deliver just one, that is the most important. The quantity control of the water that helps. The other or the last challenge is the existing problem. So as I discussed that the retrofit. So once a township or an urban area is planned, and then you go there and do a SuDS or construct a SuDS component there, it's very difficult. The next one is the urban creep. So even we have designed a SuDS element. Let's say for in the example of case study, we took a climate change factor of 20%. Sometimes it will be 40%. And currently in some parts of the Europe, they consider a factor of 40%. So if the rainfall increases, then we have to redo these SuDS component. Urban creep is like in a township, there are 10 houses, then 5 more come up. So it will increase the surface flow. Then we have to think about expanding the SuDS element. And then the climate change also discussed. So the very last, like what are the job opportunities or what's in it for me? So as I already told that this is a very naive practice in India at the moment. However, it is developing very fast. So there will be too many career opportunities in this field. And in 10 years down the line, we will not be hiring people who have drainage experience. We'll be hiring people who have drainage experience with a sustainability factor. So it's very important for people who are currently in colleges doing civil engineering, water resource engineering, or environmental engineering to go start looking at these concepts, how it is being developed across the world. Then the next target audience would be the conventional drainage experts, people like us who are already in the field, but we are only designing pipes and manuals and not thinking about the environment and capturing this water and use it for some other things. So we have to think about the sustainability aspect. So it's very important for us. Then I also talked about the spatial planning, the integration with the entire development of the site. So again, it's very important for the urban planners and town planners. Then for the architects too, because here we are having a discussion within the engineering community. But in the UK and the Europe, these green roofs, these blue roofs are usually designed by the architects. And so they tell us, okay, this size of your roof will be a green roof, and this will be a blue roof. These plants will be put, this will be the size. So yeah, in future in India also, the architects can also think about it as a career opportunity. And apart from these four, also some other fields like let's say we created a green roof, so it will provide thermal insulation to the building. So the structural or the building engineers can be involved in it. These ponds will create a cooler atmosphere, a less noisy environment. So even the environmental enthusiast may have some benefit from learning these. So as I said, that the benefits are multiple, and a lot of job opportunities will be there down the line. And in 5-10 years, you will see these concepts all around you.